So like I said, I'm going to break down trigonometry into simple terms. And those terms are we are going to deal with situations where we have right-angled triangles. And we're going to find situations where we have only just any other non-right angle triangle. So it doesn't matter whether it's a scalene, whatever, as long as it is not right angle triangle, right? But can you see that the key word here is that when we are dealing with trigonometry, there has to be a triangle somewhere. Otherwise, the concept of trigonometry won't work. So can you see also that the word trigonometry starts with 3RI, right? So it goes along with the word triangle, right? So that's why whenever you hear trigonometry, this is just what we are going to deal with. Now, when it's right angle triangles, there are two types of methods that you can use to calculate the given information. So remember, we said trigonometry, it's all going to be about calculating angles and lengths of sides. So these are the only two things that you'll be dealing with. Calculating of angles, size of angles, and calculating of lengths of sides. Because you know a triangle just has two things. A triangle is a two-dimensional shape. It is the sides and it is the angles. That's it. So that's what you will be simply doing all along. It doesn't matter whether we are doing for right angle triangles or for non-right angle triangles. You're simply going to be doing the same thing. You're going to be calculating angles and length of sides. All right. So now, how do you do that? How do you calculate the angles and length of sides? So you do that by applying on the right angle triangles. There are two ways that you can use to calculate these two things. So we have what is called the Pythagoras theorem. I'm sure it's not your first time to hear this. Pythagoras. I have no idea if I'm getting it right. Pythagoras is going to be mad at me if I spelled it wrong. All right. So with the Pythagoras theorem, it's only going to help you calculate lengths of sides. That's all. That's all it can do. Only for lengths of sides. And for that to work, you need to have a right angle triangles, like we said. So I'm going to draw a right angle triangle, and we try to name the sides of a right angle triangle, so that when we write down the formula of Pythagoras theorem, it makes sense, right? So let's draw a right angle triangle. Doesn't matter which direction it will be, right? Doesn't have to be standing like this. It can be upside down. It can be whichever direction the right angle triangle will be. Because you're going to find questions where the right angle triangle will be sort of looking weird. But as long as it is a right angle triangle. All right. So whenever you have a right angle triangle, we can be able to name. So assume we are given this angle, and we can just call it angle theta. Okay? This is just given, it's just an unknown. Whenever we have a right angle triangle, we should be able to name the sides of the right angle triangle. How? We know always that the side that will be opposite to the 90 degree is called the hypotenuse. you'll have to forgive me with the spellings. The side that will be opposite to the given angle, right? Like in this case, you see, we have our 90 degrees. That one, you don't actually have to be given. They have to just show it. So you already know because of that, that is a right angle. So always the side opposite to that is always called the hypotenuse. And then the side that will always be opposite to the given angle. So now, with this one, I want you to know that it can always change. Because if I say the given angle was this, then it's a different story, right? You can always change, you can always interchange. It's always up to you which one you want to call the opposite and the adjacent. So assume that this one was the given one. This becomes what is called the opposite. And then the one that is below the given angle is always given as the adjacent. All right, so we can make abbreviations for our sides to say this is called A, this is called O, and this is called H. All right, so now that we know what our sides are called, now we can bring in the Pythagoras theorem. So what does the Pythagoras theorem say? Remember, all these things that I'm writing, opposite, hypotenuse, and adjacent, we're talking of the lengths of the sides. The side, the length of that side, right? So what does the Pythagoras theorem tell us? It tells us that the length of the hypotenuse, if you square it, will always be equal to squaring the opposite plus squaring the adjacent. Simple as that. So once you have that, as you can see, it's an equation. So you can always change subjects depending on what you want to calculate. So if you're given, so for this to work, for Pythagoras theorem to work, you must always have two sides. There is no other way you can use it. It must be a right angle triangle, and you must always have two sides. That's the only time you can apply Pythagoras theorem. On a right-angled triangle. Okay, I'll give you time to write. So, whenever we're dealing with the right-angled triangle, we said you can either use the Pythagoras theorem, which is what we have just discovered now, and we said this is only to calculate the length of sides. And for it to work, there must be at least two sides given. Otherwise, you can't use it. It will be completely useless for you. Okay. So assume now that you are given only one side and you are given an angle, but it's still a right angle triangle. Right? It's still a right angle triangle, but now in this case you don't have two sides. You only have one side, but at least you have an angle. What then do you do? So now you can use our SOH-CAH-TOA methodology. Right. So now, in order to calculate both the length and angles, you can use the SOH-CAH-TOA method. Right. So what does this SOH-CAH-TOA method represent? All right. So we know sin equals to opposite over hypotenuse. So remember, we already talked about what is opposite and what is hypotenuse, right? Cos adjacent over hypotenuse, and tan equals to opposite over adjacent. So SOH-CAH-TOA, you just have to know it is like this. Whenever it depends now whether you want a side or you want an angle. So the sin will always be the sin of some given angle. So I will put the theta here, sin of some given angle, or cos of some given angle, or tan of a given angle. So that's why I said you must have at least one side and one angle for this to work. At least. It can be two sides and an angle, whatever, but if you have this minimum number of things, it will be possible to calculate the rest using SOH-CAH-TOA. And remember, we said it only applies to right-angled triangles, nothing else. All right. So that is it with right-angled triangles. SOH-CAH-TOA or Pythagoras theorem. That's it. We'll see how we apply those two. Now, what about when you are given other type of triangles which are not right-angled triangles? What do you do now? Okay, so when you are given other triangles which are not triangles, you use two rules, the sine and cosine rule. So again, sine and cosine rule, they are used to calculate the length as well as the angles. All right, so let's start with the sine rule. So again, we assume that now it's just a triangle which is not right-angled triangle, right? But again, as always, you always have a triangle which we can call A, B, C. So remember, the capital letters of a triangle, they always represent the angle, and then the length of the side. So the length of the side which is opposite to A, it's always represented by a small. The length of the side which is opposite to B is represented by a small. And then the length of side which is opposite to C is represented by a small c. So capital letters represent the angle, small letters represent the length of the side. Okay. So now that we have named our triangle ABC with side small a, small b, and small c, and angles A, B, and C, how can we apply the sine rule? So the sine rule says the sine of angle A over the side A will always be equal to the sine of angle B over the side of B, and it will always be equal to the sine of angle C over the side C. You can write it in other words to say the side A over the sine of angle A is equal to the side B over the angle of sine B equals to the length of C over the sine of angle C. That's just how you use the sine rule. Is it difficult? The formula itself is easy, right? So it's only the application that we'll need to worry about. So that is it with the sine rule. And as you can see with the sine rule, you don't have to remember everything because you know it's just switching the denominator. You can either start with the angle and then the side, or you can start with the side and then the angle. And you only need to remember the one because everything else is the same. It's just different sides. Okay. So application only is the one which is important here. Now, how about when it comes to the cosine rule? Okay, so the cosine rule, it's also to calculate the length as well as the angles. Okay, so what does the cosine rule say? So we will draw our triangle again as it was, the one where there is no 90 degrees. And we will name it A, B, and C. Again, the side opposite to B is small b. The side opposite to A is small a. The side opposite to C is small c. So, with the cosine rule, you can find, like we said, you can find the side or you can find the angle. So I'm going to just give you the formula for finding maybe one of the sides and finding one of the angles. The rest will be the same thing, you will just be changing the letters. I'll show you how the differences are. So, for finding the length of sides, so let's say we want to find the length of A. So, what the formula will be, A squared equals to B squared plus C squared minus two BC cos A. Is that difficult? If you want side A, you simply add side B squared and side C squared minus 2 times B and C, as you can see, the 2 times B and C, and then cos A. So let's try to do the one for B. Let's say you want B squared. What do you think is going to be? A squared plus C squared minus 2 AC cos B. It's like physics, eh? And it's so easy, right? What about if you want C squared? It will be A squared plus B squared
minus
2AB
cos C.
That's it. That's how you find the length of side. Right, now I'll give you the last one and then you can write. And then after that, we jump right into questions because that's all. Remembering the formulas is very easy. The only thing that you need to be able to do is when you look at a question, make your decision. First of all, is it a right angle triangle? If it is, then you know you're not going to worry about cosine and sine rule. Alright. Am I given two sides? Yes. Pythagoras theorem is always the easiest one. I'm not given two sides, but it's still a right angle triangle. SOH-CAH-TOA. That's it. Is my triangle a non-right angle triangle? Yes. Am I given at least two sides and an angle? Yes. So I'm going to use my sine rule. Am I given nothing at all in terms of angles? So I'm going to use my cosine rule. Right. So let's write the last one, which is for size of angle, right? Because remember, on cosine rule, we have the length of side, and now we need the size of angle. And I want you to notice that the size of angle formula simply comes from the length of side formula. We're just now changing subject. You know what we do with change of subject, where we take things that we don't want, we put them the other side and make x the subject of the formula, that kind of story. So that's what we need to do now here. So let's say we want angle A. What are we going to do? So angle A, as you can see, it comes from here. We want to leave cos A on one side and everything else on the other side. But as you can see in our formula there, our cos A is together with 2BC, right? And it's negative. So the wisest thing to do is to make it positive, it must come to the left side, right? And then A squared goes to the right side. And then later on you just divide by 2BC, and then you are left with your cos A. Let me see if we can understand what we're saying. So I will summarize the formula, but now I just want you to see where it comes from, in case for some reason you forget it. It's always good to know, okay, if a formula you can find out how it came, you can always find it. So A squared equals to B squared plus C squared minus 2BC cos A. So remember, now we want the angle A. So if I do, like I said, I want to do change of subject. I'm bringing this one to the left hand side and taking the A squared to the right hand side. So what the new value becomes 2BC cos A, right, equals to B squared plus C squared minus A squared. So far so good. And then lastly, since I want only to remain with cos A, because I want the angle A, I will have to divide by okay. So in other words, the formula for cos A equals to B squared plus C squared minus A squared over 2BC. That's the formula for A. You do the same. What do you think the formula for cos B will be? Without changing the subject. Cos B, it will be A squared plus C squared minus
B squared
over
2AC.
Very simple. We do the same, the last one. What do you think cos C will be?
A squared
A squared
plus B squared
plus B squared
minus C squared
minus C squared
over 2AB.
2AB. That's it. That is sine and cosine rule. And as you can see, if you just remember the formula for calculating length, you can use change of subject to find the formula for calculating the angle. So now, like I said, the only task now is how do you apply these formulas? Now that you know them, now that you have them, how do you make use of them? So you can write, and then we can now go to questions, because that's all we need to know about cosine and sine rule. You scroll down when you are done and write out. So, hurry up. All right, let's start with question 1 then. Question 1 says, a triangle has sides 6 centimeters and 5 centimeters the angle between these two sides is 150 degrees, calculate the area of the triangle. Okay, so we didn't cover the formula, but I think we can do it now so that we know how to calculate area as well. Area of a triangle, which is not right angle triangle. Remember we introduced the concept of area of a triangle before, where we say half base times height. But now, since this triangle is not a right angle triangle, clearly it's not a right angle because one of the angles is 150, so there's no way it can be a right angle, right? So area of a triangle in that case non-right angle triangle. It's simply the same as half, but instead of base times height, it's now any two given sides, and then sine the angle. So angle always represented by theta. So remember, we are given that we have a triangle like this. Where this angle is 150, and then we're given that the angle, that's the angle between those two sides. So which means this has to be 6, this has to be, the other ones we don't care what they are. But the idea of an area of a triangle is that you must find the sides that are between a given angle. So you can't, if this one was given as 10, you can't come and put half of 6 times 5 sine 150, because it has to be between those two given sides. That angle, this angle here, must be between the two given sides. This given angle must be between given sides. Otherwise, it won't work. But in this case, it will work because that's what is given. So, in order to calculate our area, it's simply half of 6 times 5 times sine 150 degrees. So, I'm sure that can be calculated in our calculator, right? So, it's 1/2 times 6 times 5 times sine 150. So your answer will be
7.5.
7.5 what? Centimeters squared. I mean, there's nothing complicated about that, right? But very careful whenever you're using the area formula. Always know that the angle has to deal with you always choose the sides that are sort of forming the angle. You can't use the sides that are not forming the angle, because that's the mistake that students give. Let's say that thing was given with all sides like that. You can't take 6 times 10 and then 150. It has to be the one that is between the given angle. You can't use the 10 since the angle that is given is between 6 and 5. If the angle that was given was between 6 and 10, then we can use the 10. Yes. If the angle that was given was between 5 and 10,
So you only use the two numbers where
the ones that are forming the angle. Yes. Always the ones that are forming the angle. So that's the only trick that they will try to get you with. They can give you a graph like that, a triangle like that, where all the sides are given and just one angle. So they want to know, are you able to know which sides to choose? So it only has to be between the angle, the sides that are forming the angle. That's the ones that you choose. Okay, is that done? We can move on. Question 2. Question 2 says, in triangle ABC, right? So you can see it because it's drawn for us. Angle BAC is 90 degrees, which is clearly indicated. Angle BCA is 55 and AC is 20. And then the triangle initially stood with AC on the horizontal surface. It was then rotated about the point C onto triangle ABC with those funny things. Where angle ACB, where ACB is a straight line. This whole thing is a straight line. Calculate the length of BC, the distance A to B. I don't know what to call that thing, but you can see it.
Is that the complement?
Yeah, we can call it complement, yes. A complement, but it's more like a reflection, an image of B, but let's call it complement. And then the height of A complement above CB complement. All right, so the first thing to know is that the triangle ABC, it's a right angle triangle, right? We are given one side and one angle. That's the only thing information we have. So are we going to use, remember our choice, we said once it's a right angle triangle, we know there are only going to be two things, either Pythagoras theorem or SOH-CAH-TOA. Can we use Pythagoras theorem? No, because we only have one side, which is the 20. But can we use SOH-CAH-TOA? Yes, because we have a side and an angle. But now it's going to be now a choice of which part of SOH-CAH-TOA are we going to use, which will not be so difficult to do, right? So let's look at what they want first. They want the length of BC. So in this case, BC is our, from triangle ABC, BC, is it an opposite, is it a hypotenuse, or is it an adjacent?
Hypotenuse.
BC is the hypotenuse. All right, so very good. And the given side, AC, is it the opposite or the adjacent?
Adjacent.
The adjacent. So we have opposite, we have adjacent, and we want hypotenuse. So are we going to use SOH-CAH or TOA?
So we have the hypotenuse and the adjacent.
Yes.
CAH. We're going to use that.
Agree? We have the adjacent, we want hypotenuse.
We want the hypotenuse.
Yes.
So it's
not
so it is
TOA.
the TOA.
We can't use the TOA because TOA doesn't have hypotenuse, does it?
But you said we want the hypotenuse.
We want the hypotenuse.
So we can use the CAH, the CAH,
Do you agree?
or the SOH. No.
We want the hypotenuse.
We want the hypotenuse,
Mm.
and we are given adjacent.
Adjusting and opposite.
So in other words,
Mm.
the sides that we are dealing with, it's adjacent and hypotenuse. Remember, we want hypotenuse, it's not there, but we are going to work with it.
So it's CAH.
So it's CAH, right?
A.
That's it. That's always the way you have to think about it. What do you want? What do you have? And look at which of those SOH-CAH-TOA has both of them. We want hypotenuse, we have all adjacent, so it's CAH. It doesn't matter whether we have it, we actually have the hypotenuse itself, but we know we want to work with it. So it's CAH, right? We totally agree. So if it's CAH, we know it's going to be cos of the given angle, which is 55 degrees, right? Equals to adjacent, which is
20.
over H. Our H we know is BC, but for now we'll just call it H. So now, simple, we do what is called cross multiplication to make our life shorter. So this one comes there, the h goes there. Right? So it becomes h equals to 20 divided by cos 55.
But when the cos comes this side, doesn't it have to be negative?
It doesn't, because here I did not move to I did not do like from one side to the other. I cross multiplied. What I did is I did a shortcut of this. Right?
So it's 20 divided by cos 55.
Yes, 20 divided by cos 55. Yes, 34.86. They always want you the answer to, I think, 3 significant figures. Look at here. If the degree of accuracy is not specified in the question, and if the answer is not exact, give the answer to 3 significant figures. Right? But give answers for angle sizes to 1 decimal place. But that's for angles. This is not an angle. This is a length of side. So, what answer did you get?
34.
Point.
So it will be 34.7.
Alright, is that correct? Do you agree? 20 divided by cos 55. 34 points?
Sure. What will you round off with?
To 3 significant figures.
So it will have to be 3 numbers after the comma.
No. That's the difference between significant figures and decimal places.
So it's 34.7 or 0.9.
Very good.
Yeah, 34.7.
34.9. Because 3 significant figures you calculate from the significant figure, and any significant figure is regarded as from 1. 0 is not significant. So 3 is significant. So we count 1, 2, 3, meaning we land at 8, but then you look at the next one after the 3 significant figures. In this case, it's a 6. So since 6 is from 5 and above, we make the previous one higher by 1. So this becomes a 9. So 34.9. What about if they wanted it to 3 decimal places? What would be the answer?
34.869.
Very good. If it was 3 decimal places, that's where we start counting after the decimal point. 1, 2, 3. You look at the fourth one, which is a 9. So making the 8 a 9. So that's, don't confuse the two. Significant figures and decimal places. So our final answer is 34.9 centimeters. Therefore, BC is 34.9. Now, of course, we don't know whether it's centimeters or what. We just say 34.9. Therefore, BC equals to 34.9. Question B. Question B wants the distance A to B complement. Right? A to B complement is from here all the way to there. A to B complement. Do we know this distance from C to B complement? Don't we?
But doesn't it have to be 180? Because
We're not talking of angles, we're talking of distance.
It's 34.9.
It's 34.9 because we know it's the same triangle that was just twisted around, right?
oh,
So BC from the old image is the same as B complement C, because it's the same. So we know that this part is 34.9. This part we know already it's 20.
So it will be 54.9.
Very good. Not complicated, eh? Straightforward. Now they want, what is the height of a complement above the line CB? So they want this height. Remember, C to B complement is this from here to there. They want this height. They want to know what is this distance. Do we agree? What is the height of A complement, which is this one? Above CB means above the line CB. So they want to know this distance. Was that obvious? Was that clear to you before I drew the line? The question you have to ask yourself, it should be straightforward. Height of A complement. Where is A complement? There is A complement. Above CB. What is CB? CB is line CB, right? Which one is line CB? Line CB is here. So they say the height. So they want this distance. Isn't it? Okay. So since it is a perpendicular distance, we know immediately that this becomes whichever direction you want. It's 90, 90, right? Now, do we know the size of this angle? What is it?
55.
Do you agree? You agree, right?
Yeah.
It is 55 because it's the same triangle. Nothing changed about this triangle. And we knew already angle C was 55. It's still angle C in this case. So we know that this is 55. So, can you see now what we have in this case? We have side A complement to C, which is how long? What is the length from A complement to C?
90.
No, the length of the side?
20.
20. And we have an angle C, which is 55 degrees. And we want this side, A complement to the line CB, which is, we want this side. So if we are just working with this triangle, what is that height that we want? Is it the opposite? Is it the adjacent? Is it the hypotenuse?
The opposite.
It is the opposite, right? Because it's opposite to the given,
90.
to the known angle, to the angle that we know. So we know that the height that we want is the opposite. It's opposite to the given angle, which is 55. We also have A complement to C, which is in this case our, is it our hypotenuse, is it our opposite, or is it our adjacent? Okay, so I see where the confusion is. Remember I told you last time that try not to look at the whole picture, just work with what you are dealing with. So I'm going to remove it from this picture and draw it somewhere else, separate.
Show the 20.
So what I have drawn is, we have something like this. We have C here, A complement here. Here we don't know what it is because there is no point here. But we know that there is a 90 and we have a 20 and we have a 55 degrees. We are not working with this whole triangle. We are only working with this one. Is it?
Even C still the adjacent.
Now that I removed it, are you still staying on that position? Now look at it. Don't look at the original now. Look at the new image. What side is this?
Oh, no, C is the opposite.
This side is now opposite. This side is
adjacent.
This side is.
Hypotenuse.
Do you agree? Because we always, whatever is opposite the 90 degrees is always our hypotenuse. We are no longer working with this whole triangle ABC. We are now only working with this because we made our own line because they said they want the height of A from CB. So now we have a new triangle because as soon as we introduce that line, we came up, we now have a new triangle. In that new triangle, 20 is no longer adjacent. In that new triangle, 20 is actually a hypotenuse because it's opposite the 90-degree angle. In that new triangle, the height that we want is the opposite. And the other side that we still don't know is adjacent. Do we agree on that?
Mm.
So now that we want opposite and we have hypotenuse, so O and H, which one are we going to use?
C.
Sin. So sin 55 degrees equals to opposite over hypotenuse. Right? So in this case, we are simply multiplying this one to there. So it's going to be, our hypotenuse, we know it's 20 sine 55 equals to O. Tell me if we're still together. I don't want to lose anyone here. 20 sine 55. 16.4. So O equals to 16.4. Therefore, the height of A above C of A complement above C B complement is 16.4. Guys, I don't want to lose anyone.
Why couldn't we use the first method that we did for A?
Why didn't we use CAH? Okay.
No, not saying car, but the way we did with car. Why couldn't we just bring the cos like on top of like O instead of?
Oh, okay, very good. In this case, remember what we have was 20. We already have this. Okay, sorry, here, let me not write H. In this case, what we have was, we already have the 20. Right? Because it was opposite. Sine, remember, so means opposite over hypotenuse, right? So we already have hypotenuse, we don't know the opposite. So what I'm doing is just a shortcut. Let me show you what I'm doing here so that you understand where it comes from. What I did with this first one, if we were to go the long way, what were we going to do if we're going to go the long way? The long way is whenever you have a fraction, the first thing is to get rid of the fraction. How do you get rid of the fraction? You multiply both sides by the denominator. So we're going to multiply here by H. We also do what we did. What you do on the right side, you should do on the left to make an equation remain the same, right? So at the end of the day, this was going to cancel that. So you're going to have h cos 55 equals to 20. But remember, we want h. So how do we get rid of cos 55 so that we only have h? We divide both sides by
Cos 55.
so that at the end of the day you have h equals to 20 over cos 55. But you don't want to continuously be doing that. You can simply do cross multiply. Similar, that's what we did here as well. We said sine 55 equals to opposite over 20. How do we get rid of the 20? Multiply both sides by
20. Okay. Now, okay.
so 20 sine 55 equals to O. So to make your life easy, just know you're always cross multiplying. As long as they are standing like that, cross multiply. Meaning the one that was in the numerator comes to the denominator, the one that is on the denominator goes to the numerator, depending on what is the unknown in that question.
This was a choice.
For me, on this question, what was important is knowing that when they asked that they want the height from of A complement above CB, to recognize that we are working with a new triangle. And whenever there is a new triangle, your opposite, hypotenuse, and adjacent changes. It's no longer the same. So while 20 was the opposite in the previous triangle, in the new triangle, 20 is actually our hypotenuse. So you have to recognize that. So if it's difficult to recognize from the while it's drawn in the original image, just remove it from the original image and work with it separately. Then it becomes much straightforward and simpler. Okay, so do you want to write that down now? Or you already done that? Okay, excellent. So let's move on. So guys, the diagrams, if the picture is too overwhelming for your eyes, just remove the part that you want and work with it separately. Is that fine? There's nothing wrong with removing it and do it separately so that you have a clear view of what you are doing. One thing is already obvious for us, right? Even just by looking at the diagram, that we are not going to be able to use Pythagoras theorem and SOH-CAH-TOA at the moment, because none of those triangles, whichever one you look at, is right angled. So it's going to be sine and cosine rule somehow. Right. In the diagram, the quadrilateral ABCD represents a level arc with a path BD. AD is that, so they are just simply telling us what they already drew. So that's what this whole nonsense is about. So we can simply move on to what they want us to do. So they want us to calculate angle ABD. So we already talked about this. Whenever they want the angle and you're given 3 letters, we're referring to the letter in the middle. Right? So ABD means they want this angle. Okay, so with that angle, I was able to calculate it using sine rule or with cosine rule. So here's the secret. For you to apply the sine rule, remember we have two sine or cosine rule, right? For you to apply the sine rule, if you are looking for the angle, at least you must have the side which is opposite to that angle. Do we have the length of the side opposite to that angle? Because the angle that we want is this one. The side opposite is this one. Do we have it? We don't have it. So immediately you can't use sine rule. So which leaves you cosine rule. And we gave formulas for calculating the length of side of the length of the size of an angle for cosine rule. Yeah, so in this case we want cos B. So cos B equals to the sides, which is 600 squared plus
600 squared.
What is wrong with these guys? Even our cosine rule is going to be difficult to use.
Why?
Because we don't have that side.
Okay.
Oh, okay. It won't be difficult to use.
We're using the 600 and the 950.
Yeah?
We're using the 600 and the 950.
We are using the 600 and the 950. But we still need to know one of the sides if we're going to use. Because remember, our cosine rule, as you can see, it uses 3 of the sides for the angle. The formula for the angle. It needs all sides, a squared, b squared, and c squared. But we only have 2 sides. Is that making sense what I'm saying? That in order to get angle with our cosine rule, we need at least we need all 3 sides, but we don't have 3 sides. So what does that mean? What it means is, what I'm seeing is, since this question has got 4 marks, they want us to do 2 calculations here. That's why it is a lot of marks like that. So what we can do, we can be smart about it, right? How? We know a triangle has got just 3 angles, isn't it? So if we find 2 of them, we'll be able to find the 3rd one. Is that correct? If we find at least 2 of them, we should be able to find the other one. So although we want angle B, clearly we tried to use sine rule, it was impossible. And we tried to use cosine rule, it was also impossible for us to get directly the angle that we want. But what if we find another angle that is unrelated to what we want and then come back to what we want? Will that work? So in that case, I'm trying to say, what if we find this angle? Right? So if we find this angle, it will be possible to find B, right? Because now we will know, we will add that angle to the 118, we subtract whatever we get from 180, isn't it? So my point is that the way the question is given, we can't directly find our B, but we can find angle D and then use our knowledge that total angles in a triangle are 180 to find the one that we want. Alright, so that's what we're going to do. So, since we are now finding D, we know that there is the opposite of D. The side is given. And also A, 118, opposite of it, the side is also. So we can use our sine rule, right? And we're going to use the sine rule whereby the angles are on top, since we want the angle. Huh? So, in other words, we want sine D over the length of the side which is opposite to D, it's 600, must be equal to sine A, which is sine 118, over the length of the side opposite to A is 950. Are we together and do we agree so far? Do you agree? Remember, we are not, so far we are not calculating the angle that we actually want. We have decided to calculate angle D. And with angle D, your sister has the question there. With angle D, we don't know it, the angle itself, but at least we know the side which is opposite to it, which is 600. So according to sine rule, the sine of that angle over the side which is opposite to that angle must be equal to also another sine of another given angle divided by the side of another given angle. So that's my question. So far, are we in agreement on what I have written? And you saw where it came from, right? All right. Good. So now that we have this, first thing, remember we want to remain with only sine D, right? Because that's the unknown. So what do? Multiply by so you will remain with sine D equals to, we use our calculator there to find sine 118 over 950 times 600. What do we get? Do we also get 0.557655131113?
You are all those things.
We are not yet done with the answer. So far, I'm just asking, when you put this whole right side, are we getting, when we enter all this, like we did here, on your calculators, are we getting the same answer? 0.5576. What is the rest of the number?
0.557651.
111. Last number?
1.
Oh, it will continue with ones. Okay. Okay, there's a reason why I'm not rounding it off yet, because we're not yet done with the answer, right? And I will also, so you're not going to do anything on your calculator. Don't delete, don't clear. Let's stay where we are at the moment. And I ask you again, are we together so far?
No.
No one is lost? Okay. So remember, what we want is angle D, right? So at the end of the day, once you reach this stage, every time you're going to be doing your calculations, once you reach this stage, and remembering that you want the size of the angle, D, angle D, and I like representing the angle with the angle sign on top to show that we're talking of the angle. It will be the inverse of sine for that number, whatever that number will be for you in that question. So, in your calculator, without doing anything, without changing, what you simply come and do is, you come and shift sine -1, answer. Shift with second function, sine -1, which will be on the side, answer. Yours, for you to press answer, you see it's in green. So anytime you want to use anything in green, you first press alpha. Very good. Equals.
Yeah.
Excellent. So everyone has the answer. So now that answer is in degrees. With cast your calculators or your calculators, I always want you to check. Can you see here? It's showing D. Make sure it's showing whenever you're dealing with degrees. If it's not showing, if it's showing R, please reset the calculator so that it shows D. Yeah. Notice it sharp shows deg, meaning degrees. Okay, so always make sure that your calculator is showing in degrees. So our final answer for angle D is, remember they said for angles, if we don't know the answer, we round off to? For angles. One decimal place. They didn't even say significant figures, they said decimal place. They said one decimal place.
It's 33.9.
Thank you. .9 degrees. But remember, that's not what we actually want, right? So now to finish off what we want, we know that therefore angle ABD will be equal to 180 minus 118 minus 33.9. Because we know that the total of all the angles in a triangle must give us 180. We now have two of them, so we should be able to find the rest. .1 degrees. Okay, so let's talk about that question. First of all, we tried to calculate angle B directly using sine or cosine rule, and we failed because for angle B, both the angle and the side which was opposite to that angle were not given. So it was impossible to find B directly using sine rule or cosine rule. But we were smarter than the question because we knew from geometry that the sides, the total of angles in a triangle is always equal to 180. So knowing that, we knew that if we can find angle D, which is possible because of the given information, if we are able to do that, we will then be able to find the remaining angle. So that's what we did. So now we went on to know that, okay, since we want angle D and the size of the length of the side opposite to angle D was given, and we also had another angle which also had its pair of side, so we knew we could use sine rule. Knowing that, we solved and we found the angle D. And then we applied our knowledge of triangles that total angles must be 180. So which means to get the remaining one, we subtract the 2 that we now know from 180. Any questions on that? Straightforward? All right, excellent, I like it. So it's good that we did a question like this, so that when you try to do it, or when you encounter something like that in the exam, you don't panic to say, okay, I want angle ABD. I tried to use sine and cosine rule directly and none of them is working. Oh my goodness, what am I going to do? No. Always know that the reason why you're doing all the topics of maths is so that you can always relate to other topics that you've done before. And in this case, our knowledge of geometry and knowing that total angles is 180 helped us to know that, okay, even though we can't do directly to find B, we can find the other one using our sine rule and then use our previous knowledge to do the rest. Is that okay? Now, how about they want the length of CD. So they want this length. The length of CD player, yes. All right. So now we're working with that particular triangle. So we have two sides, right? And we have an angle, right? And we don't know one side. Sine or cosine rule?
Cosine.
Cosine, because we can't use sine, because for a sine we must have at least two sides and an angle. In this case, for us to find the length of that angle, one of the other given sides must have its angle, but it doesn't. So we have to use cosine rule. And we're using cosine rule for finding length, right? Okay, so your cosine rule, a squared equals to squared plus c squared 2 cos. All right. In this case, we want CD squared. It will be equal to 950 plus 1040 minus 2 times 950 times 1040 times cos 42. Are you okay? Go together? No one is lost? So,
But when you were writing that, I said the cos is a negative number. The cos was a negative number. You're talking about cos being negative. When you were like writing down the notes, you said the cos is a negative number because of the minus in front of the 2.
oh, that time I said cos, because remember this is one term, isn't it? So I said, remember it's one term. It's not two separate things. It's one single thing. So I was talking about that negative, to say that term is in negative format. So when you take that term to the other side, it becomes positive. Alright. So, when you are at this stage, it's up to you whether you want to do step by step or you want to just put everything in the calculator. I will just put everything in the calculator and move on to the next stage.
But then sometimes you just have, before you put everything in the calculator, you need the marks. Because the moment you put everything in the calculator, it becomes too small in the teacher.
I get you. I get you. So you want to go step by step to make it look like you did a lot.
Because the moment you put everything in the calculator, it becomes small.
Yeah.
Then you look at the mark and the marks are like 4 marks.
But you see, in this case, they know that whatever answer you're going to write from here, it came from you having written that correctly. Because if you had not written this correctly, you would not have managed to get this answer. So from here, we are just having our answer, which is 515-645-8249. Can you do that, please? Can you put that whole thing in the calculator? 645. And see if we are getting the same answer. So don't fear to lose marks here. Once you are able to put these correctly like that, you are completely allowed to just put in the calculator and get to this stage.
515-645.8249.
Excellent. Please do it. Because you see, the reason why I'm asking you to do it is many students, they get it wrong when it comes to the calculator part. They will write for you nicely like that. Time to enter in the calculator, things start to go wrong. So you have to get very much acquainted with your calculator. It has to become your friend. Okay, so far so good. We are at this stage. But we are not yet done, because we do not want CD squared. We want only CD. So how do we get CD? So to get rid of the square sign, you find the square root of the other side. So we have to find the square root of that number. Are you coming up with 515-645.8249 in your sharp? So, without doing anything here, I find square of the answer. Alright, square root of the answer.
Mm-hmm.
718.08.
So, because this is not an angle, so it's 3 significant figures.
3 significant figures. So it will become
718.08.
Mm-hmm.
You take out the 0. Oh, it's just 718.
Excellent. So
Let's say when I have to write this on my assignment,
mm-hmm.
do I have to start with this A, B squared to suppose?
Yeah, just to show the formula.
Oh.
Yeah. Because that's what I was saying, that at least once you show that you know the formula, that's a mark. Know how to put the things inside the formula, that's another mark. So you don't really necessarily need to now do stage by stage, calculating here, calculating there, it will just waste your time. So from here, you can just put everything in the calculator and come to this stage. Because there's still more to do. Introducing the root sign, finding the answer, and then rounding it off to 3 significant figures. So CD equals to 718. To 3 significant figures. That is worth 4 marks, isn't it? So cosine rule is quite simple for finding the length. Number 3 says, find or calculate the shortest distance from C to BD. So it's similar to what we've done that other question, where they wanted the height of A from a certain line. So they want the shortest distance from C to BD. So from C to BD, shortest distance must be such that this will be 90 degrees. That's the only way it can be the shortest distance. As long as from C to the point where it touches D, it must be perpendicular. That's the only way you can find the shortest distance. If it slants, it will never be the shortest. So far, as soon as I introduce that line, are we together there? We're together? I introduced that line, the red line, and when I went to touch line BD, I indicated that they are going to be perpendicular to show you that it's the shortest distance. So now, can you see now what I am working with? I am now working with this triangle. I think it can be prettier a bit.
Now isn't now D out?
D is now out. So the triangle that I'm working with, I've clearly marked it in red for you there, which is a right angled
Triangle.
right. In that right angled triangle, yes, question.
If D is out, but then the question says the shortest distance from C to B.
They want the shortest distance from C to BD. So they just want this distance.
Or from the line BD.
Yes, they want from C to the line BD, to where it joins BD. So they want this distance. So what we want is this. That's what they want. So based on that triangle that I drew in red, and knowing that in that triangle we have a given angle 42, that line that we want, that shortest distance, is it the opposite? Is it the adjacent?
The line is the opposite.
The line that we want is the opposite. Great. Next,
Then the one of them.
what other line do we have, which is BC, considering that triangle?
It's the hypotenuse.
Is it the hypotenuse or the adjacent?
Okay.
is the hypotenuse, because it's opposite to the,
90 degrees.
so H. So we want our O, and we also have an H. What are we going to use?
What is this? Understanding. The C.
So. So we're going to use so. So sine 42 equals to opposite over hypotenuse. Cross multiply 1040 sine equals to, from here, we don't waste time because we're given the gift of a calculator. $695.89583 blah 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 blah. This one is a length of a side, so we wanted to three significant figures, making it what? Final answer. Are you getting the same value like I did?
Yeah.
Three significant figures.
So it's 695.
Do you agree? 695. So you agreed without actually looking at the thing.
I saw you serious.
I said 696.
So what is the correct answer?
695.
Guys, what is the correct answer?
695 degrees.
No, 609. We're not working with angles.
We're not working with angles, we're looking at the length.
So it said 695.
Do you agree?
Isn't it 96?
Why?
Because we are rounding up the
8?
to the side.
So I was multiplying the first time.
But I asked you, you should have said yes, I'm sure. Me, I just want somebody who's confident with their answer. I didn't say it is wrong, I just asked again. Yeah? So if I ask again and then you're not sure, that's why you always change. Like, now I think it's 695. If you're sure of the answer, you don't have to move. You stay there. Stay
Not the way you asked me.
Yes, I have to do that to make you doubt your answer. Right?
Okay.
I just wanted you to doubt it. But you don't have to. If you are sure what you did is right, you stand there, you say, yes, I'm sure. That's standing your ground. So, you look at the 8, it's more than 5, so we make the 5 to be 6. So 696. And like we said, here, all the things are given in meters. So if you want to put your answer, it should be in meters. So the shortest distance from C to BD is 696 meters. It's similar to that one that it has to be meters. Whenever units of measurement are given, always put them, don't leave them out. Otherwise, it's a half mark that will just go away for no reason. So, I think it's now the second time we've done a question whereby they want the shortest distance or they want the distance from a point to a line. So now that you know that it's just you draw the line, and when you draw the line, it will immediately form a right angle with where it intersects that line. Right? So you must now know that it becomes a right angle triangle, and you now only work with that particular triangle. Like in this case, It's nice to notice that D immediately fell out. So we didn't even care what that length would be because there was no need for us to know it anymore. It was no longer 950 because it was not going all the way to BD. All right. Let's see what B says. A helicopter flew directly above the path BD, at a constant height of 500 meters. Okay? Calculate the greatest angle of depression of point C as seen by a passenger in the helicopter. Okay, so we're going to try to draw it. So we know that this helicopter is going to be flying directly above the line BD, because they say that directly above the line BD, the path BD. So this line that I put the dotted line, don't think of it as if it's on the side of BD, it's on top, it's directly on top of BD. It's just that we can't draw 3D here. But think of it that they're like this, these lines. It's not this side. It's not this side, it's actually directly above. Ne? Are we together on that? And we know that that distance from the line BD to that line is 500 meters. Right. Now, if we know that it's directly above, right? We know that this angle will be 90 degrees, right? If we draw any line that joins from that path, we have two lines, if you join that path, those two paths, it will definitely be 90 degrees, or if they will meet at right angles. Now we're saying somebody is somewhere in there in the plane and is looking outside the window to point C, because they said calculate the greatest angle of depression of point C as seen by a passenger. So somebody is looking from there. Let's say he's looking from here and he's looking directly at C. So far, so good. They are saying now what is the angle of depression, meaning, okay, so I'm going to turn our graph around maybe so that it makes sense. But in other words, what we have is this shape, that we have somebody who will be in the plane at this point. We can call it whatever, the plane, we can call it point P. And directly, this plane is directly above D, right? So you know that there is also a 90 degree that is formed here. So now, what I want to do is, I want to assume you are looking from this side so that you can see what that shape is looking like. Because like this, it's not looking so good. Let's say you are looking from this side. If you are looking from this side where I put the green arrow, this is how this thing will be showing you. It will be showing like this. This will be your C. This will be your plane. Right? this will be 500 meters, because this point going whichever direction, which is, we can't actually see the line BD, but we know if we are looking from where I put the arrow, D will be at this point. D will be somewhere there. So there is the diagram that we have, that it will be looking exactly like this. Now they want the angle of depression. So there's a reason why they made us calculate this thing here. There's a reason why they made us calculate this thing here. Because what they actually want us to be able to see is that when we had a line which was forming 90 here, right? So for you to have the angle of the greatest angle, meaning the biggest one, that person cannot look at the plane from when the plane is still here, not when the plane is still here. He has to look at C when it's directly perpendicular also to the point C. So that's why we know that this distance will be equivalent to the answer we got in 3 above. This distance, C to the line BD. It will be, what did we find? 696. And we also know that the height from the line to the plane, we know it's 500, which we have here. Right? So there is the two things that we have. And they want the angle of depression, meaning they want which angle? Remember, it's from the person who is looking from the plane. So we want this angle, not this one. The person is looking down at C like this. So we want this angle. But if the person was looking from C, we would be wanting this angle. This person is looking from the plane, which I tried to draw. My plane looks awesome. The person is looking from here. So the angle that we want is this one. The idea is, are we able to just construct the triangle? Once we're able to picture it, I'm sure you can now see that it becomes so simple and straightforward, because now we know we have a right angle triangle, right? And we have, if we want this angle, if this is the angle we want, this means this will be your opposite, right? And this will be your adjacent, right? So what we have to use is tan. So we know that the tan of that angle that we don't know equals to opposite over adjacent. So in order to get that angle, it's simply the inverse of tan of that answer. And remember, for angles, we round off to 1 decimal place. Shift tan minus 1 . 54.3 degrees, 1 decimal place. Okay. So the reason why they made us calculate number 3 to get the shortest distance from C to BD is so that we're able to do B. Somehow they had to be related.